Hello and good day. In algebra, we are going over the answers for CO11, absolute value, before getting into CO12, which would be our objective for today. And my understanding is that you did do a little bit with absolute value equations last year, perhaps during distance learning. So there is some background knowledge there, perhaps more than others, kind of depending on how the whole distance learning experience went for you. But hopefully, if nothing else, I was able to adequately articulate what absolute value within an equation means, okay? That we are thinking that, that n plus 1, whatever value that is, it's a distance of 66 from 0, which is where we get those two possible answers, okay? And where our two equations come from here. That n plus 1 is equal to 66, or n plus 1 is equal to negative 66, and then solve it from there. So these three, when we went over in these four actually, went over in their entirety. Any follow-up questions that you have on this? The bulk of your test is actually going to be on the second part of this, that absolute deviation piece, because it's where, it's the absolute value concept, but it's in a more real life situation type of thing. So I think one question on your test is an equation. So if you do want to get a 4 out of 4, you will need to know how to solve something like this, but the bulk of it will be the absolute deviation stuff. But these two on the back, we started, and I asked for you to finish. And the difference here is that you've got that coefficient out in front. And the point that I want to make here is that absolute value bars, they differ from parentheses in a number of ways. One of them is that you cannot distribute in, okay? Cannot distribute in. But since we're multiplying 6 by n minus 9, it is okay to divide both sides by 6 to cancel that coefficient out. So it's alternative to distributing. Divide by that coefficient, and we'll get the absolute value of n minus 9 equals 3. I think that's where I left off with you, yes?
Sure.
Yeah. So then, recognizing that n minus 9 is a distance of 3 from 0, that means that n minus 9 can either equal 3 or it can equal negative 3. Okay? And we can add 9 to both sides in both equations, and n can be 12 or n can be negative 6. And if we plug those values back in, even to just this equation here, we see they work. 12 minus 9 equals 3. The absolute value of 3 is positive 3. And negative 6 minus, no, wait, what did I do wrong? Oh, positive 6. How long were you going to let me keep that up there? Oh, thank you. So 6 minus 9, that's negative 3. And the absolute value of negative 3 is also positive 3. Okay, but it's that setting up those two equations. N minus 9 doesn't change, just that 3, negative 3. And that's how we get our two answers from. So the second one, dividing by 2, that gives us the absolute value of 4n plus 11 equals 24, which means that 4n plus 11 can equal two different things. The two values that are both a distance of 24 from 0. Those values being positive 24, and those values being, and the other one being negative 24. This one doesn't work out quite as nicely as that first one there. Subtracting 11, dividing by 4. This one we get n is equal to 13/4. The other side, subtract 11, divide by 4, and I think we get negative 35/4 as our value for n. Okay. Does this ring a bell? From last year a little bit? Some shaking their heads yes, some shaking their heads no. Okay. Any questions on it? Yeah. Both, actually, right? Because both of them satisfy the requirement that n minus 9 is a distance of 3 from 0. If you plug in 12, then you would get the absolute value of 3 equals 3, which is true, right? If you plug in 6, you get the absolute value of negative 3, which is also 3. So both values satisfy the equation that they give us something that's a distance of 3 from 0. So in the past week, your mathematical minds have just been, we've gone from there being one answer to an equation to being no solution to an equation, or everything is a solution, to now there are 2 solutions to an equation. And it all comes down to recognizing what type of equation, what the context is, and what you're talking about. But yes, both are answers. Bridget.
So for these guys, there will always be 2 answers?
Yes. The only exception to that is if n would equal 0, because obviously, I mean, there's only one 0. Yeah. 0 is only, so. But yes, you'll be looking for 2 answers here. Anything else? Okay. Absolute deviation, same idea as absolute value, only our target number isn't 0. Okay. In this first one, which deals with the geometry placement test, trying to place into geometry, 80 is kind of the target score, but obviously, not everyone's going to score exactly 80. So there's an absolute deviation of 8 points, which means that 8 points less than 80 and 8 points greater than 80 still gets you in. Your range of geometry scores would be 72 to 88. 72, it's going to be more of a challenge for you, kind of on the lower end. 88, a little bit easier on the higher end. And if you're outside of this range, if you're below 72, then geometry probably isn't the right class. If you're above 88, well, then maybe we're looking at honors or algebra 2 or something like that. But for the geometry class, this would be the range of scores that they would be looking for. Okay. The map test, your RIT score always comes with a plus minus 3, meaning that if you were to close out of the test and open it again and take it the same day, there's like a 95% chance that your score would fall within plus minus 3 of the first score you got. So if you got a 230 with an absolute deviation of 3, that means if you took it again, it's very, very likely you would get in between a 227 and a 233. Okay. The bowling pins, regulation height is 15 inches, and the absolute deviation is 0.0035 inches. So the range of heights, it could be 14.9965 to 15.0035. Just subtract 0.0035 and add 0.0035 to 15. Question so far? Did this section make a little more sense than the solving the equation section? I hope so, because this is kind of the more application of it. Figure skating. Those of you that are in figure skating, do you do any show choir stuff in eighth grade? Are you allowed to go up to high school and do show choir stuff? No, not drama. Like the Company of Singers at TG, maybe, perhaps.
Yeah, that's a big
No. Anyway, so there are certain times, and maybe if you're in dance competitions or cheerleading competitions or figure skating in this case here, there are certain lengths that they want your performance to be. But they do give you a little bit of wiggle room. So the target time for this performance is 3 minutes and 30 seconds, but you can be 9 seconds shorter or 9 seconds longer and still be okay. Right? So that's the range of times that you want your program to last. And then for every point outside of that range, you lose, or for every second outside of that range, you lose a point. So for one lasting 3 minutes and 15 seconds, that is 6 seconds shorter than the low end of our range here, which means that you'll be losing 6 points. If you put an answer of 15 points, then you subtracted from the target time rather than the low end of the okay time, that absolute deviation time. Right? Good? Okay. The last one with my daycare drama. Every morning, it's just so much fun. So it takes me 24 minutes, 18 seconds with an absolute deviation of 53 seconds. So on average, you'd say most days it is that time. But on a really fast day, I hit all the lights, maybe speed a little bit. Okay, takes me. No, I'm just it's purely hypothetical. 23 minutes 25 seconds on a slower day. I could pull over because I'm speeding or something like that. It takes me 25 minutes and 11 seconds. Okay. I'm just making. It's my improv routine. I'm just kind of making it up as I go.
Maybe it's his best friend and he lets him go.
There you go. Yeah. Soybean. I was kidding. Don't get hung up with the speeding. I was just kidding. I was trying to come up with the reason why I might be faster.
Bridget will call the cop.
Yeah. So what this gives you here, that 2418 plus minus 53 seconds, is the range of times that it would take me to get here from daycare. But contextually, if I leave at 6:55 a.m., the soonest I could get here, adding 23 minutes and 25 seconds to that, is 7:18:25. Or if it's a slower day, it takes me 25 minutes, 11 seconds, then I would get here at 7:20 and 11 seconds. So this range here in context is the answer that you should have. Okay. The top range is the length of times it takes me to get here. The bottom range is the actual time I arrive if I leave at 6:55 a.m.
You should just leave earlier.
Hashtag 3 kids solo in the morning. She has to leave for work at like 6. So but here's the problem. Daycare doesn't open until 7. I pay extra just to drop off 5 minutes early so I have a chance at getting here at a respectable time.
You drop your kids off at 6, leave them there.
On the front step.
Yeah, make them wait.
Yeah, they're both just.
I feel like if I said that, I would get in more trouble than admitting that I speed from time to time. If I leave my kids on a doorstep in 20-degree weather.
That sounds like a good parent.
Father of the year. Okay. Any question on absolute deviation? All right. We are going to deviate from this for a moment. Sorry. And go to solving a literal equation, which is CO12. Literally.
Okay, I didn't get the last one.
Well, do you have a question on it?
No.
Okay. So we're still sticking in the equation realm, but we are going from given formulas, okay, to isolating a variable in that formula. So when we say isolate a variable in a literal equation is really just a formula. Shortest definition you'll ever have. Okay? A literal equation is a formula. So in an example, what we're going to be doing here, in the equation, area equals base times height divided by 2. We know that's the area for a triangle, right? And typically, when we use that formula, what values do we have? When we use that formula, area equals base times height divided by 2, what values do we typically already have? Gabby? The base and the height, right? We plug them in, we get the area, and we go on with our lives. Right? Now we're looking at, well, what if we know the area, we know the base, and we're looking to solve for the height? We did this a little bit in geometry in PO10, but the next step here, the algebraic step, is we're actually going to rewrite that formula, manipulate that formula. So instead of it equaling the area, it's going to equal the height. Okay? And we're going to start actually with the area, or with the formula for the volume of a cuboid. Right? So we work with volume in the math packets a lot. And the first two shapes that we had, one was a cube, the other one was a rectangular prism. Those two shapes we lumped together in the cuboid. Love that word. And the volume of that is found by multiplying the length by the width times the height, or the base times the width times the height. And what we're looking to do here is to rewrite this formula, not so that it gives us the volume, but so that we be able to solve for the height of the cuboid, meaning we want to rewrite this formula so that V isn't by itself, but H is by itself. Any thoughts on how we would do that? Audrey?
You could like plug in the values that you do know. So like if you say like 90 inches equal or 90 inches cubed equals 3 times 2 8.
So that's what we'll end up doing, but just for the sake of argument, let's say we don't have any values yet. So we're going to rewrite the formula, keeping V as V, L as L, W as W, H as H, but rewrite this formula so that H is by itself instead of the volume. Gabby, what do you think?
Do like L times W divided by V.
Right. So other way around actually. But yeah, you're in the right train of thought here. So just like any other equation that we're solving here, if we want to get H by itself, we say, what are we doing to H? What's being done to H so that we can undo it? What's being done to H is we're multiplying it by the length and the width. Okay? So to undo that, if we divide by the length and the width, what happens to the length and the width on the right side? They cancel out. Okay? Just like every other opposite operations equation that we've done, if you undo what's being done to the variable, they cancel out. And then on the left side, of course, we have to divide by the length and the width as well. And so this ended up being kind of a one-step process to get H by itself. The value of H equals the volume divided by, that's a sorry excuse for an L, the volume divided by the length times the width. So that if we know what the volume is, we know what the length is, and we know what the width is, we can say the height is equal to the volume, which is given to us as 90, divided by the length, 3, times the width, 2. And what do we get? It's actually not a lot.
It's actually not.
What happened to the 2?
Yeah. It's this 3 and then the width is.
Right. Length times width, 3 times 2. Oh, sorry. What do we end up with for the height? Thumper? 15. 90 divided by 6, the height is 15. Going back to the original formula, Audrey's first thought was to plug these values in. 90 equals the length times the width times the height. To solve this, wouldn't we multiply the length and width together to get 6 times H and then divide both sides by 6? 90 divided by 6. That's what we're doing here also. But the advantage here is that if we're kind of playing with figures a little bit and we want to know, given a certain volume, what could we plug in for length and width and solve for the height? If we'll be solving for the height of several cuboids, one after the other, that formula is going to get us to our answer more efficiently than plugging them in and then solving it that way there. So that's the advantage to this. Have I lost anybody, or are you all kind of with me? Kind of with me. That's okay. As long as you're in earshot, then we're doing all right. The next one, the volume of a triangular prism is V equals length times width times height divided by 3. That's my mistake. I was actually thinking of a pyramid here. As we know in our math packets for this week, the volume is length times width times height divided by 2 for a triangular prism, not 3. So change that to a 2. How embarrassing.
Did you write that?
Should fire myself.
You should. How did I fire you?
You said that with a little bit too much excitement.
Oh, goodness.
All right. So the volume of a triangular prism is V equals length times width times height divided by 2. We want to write a formula to solve for the length of the prism. So we want to take this V equals length times width times height divided by 2 and rewrite it so that the length is by itself. So just like in the previous one, we're looking at, what am I doing to the length? What's being done to the length that we'll need to undo in order to get it by itself? Elise? Sure. Like the final answer, or don't let's not jump to the final answer. Let's just what was your first step? Good. So if the numerator of this fraction is length times width times height, and we're dividing that by 2, to undo that, we're going to start by multiplying by 2. Okay, to cancel out the denominator of that fraction. So times 2, and we would get 2v equals length times width times height. Okay. Now we're in kind of the same situation as we were up above here, right? We want to get the length by itself. What are we doing to the length? What do we do to undo that? Go ahead. Divide by?
W.
Right. We're multiplying the length by WH. So if we divide both sides by WH, that's going to cancel them out on the right side, leaving us with the length by itself. On the left side, we have our formula. 2v divided by WH. So for any given triangular prism, to solve for the height or the length of that prism, you'll take 2 times the volume divided by the width times the height. So for our given values here, the volume is 100. Do over here. The volume is 100. So 2 times 100 divided by the width, which is 5, times the height, which is 10. You all right?
Yeah.
Good. What's the length of this triangular prism? Soybean. It is 4. Good. 200 divided by 50. Sorry.
Yay! You made it pretty.
Oh, if I want to make it pretty, I would have done like the little cloud thing around it, Yeah. Yes.
Why couldn't you just plug in the numbers?
Yes. So the most of you, if you're given this situation, you'd go to the original formula, plug in the numbers, and solve from there. But the skill that we're practicing here is being able to manipulate an equation to tell us something else. Last year, slope-intercept form, does that ring a bell? Standard form, does that ring a bell? Also, so when we get to graphing, there are a number of ways you can represent any equation. Slope-intercept form being one of them, standard form being a second one. The ability to convert from one form of the equation to the other, because each one kind of tells you something different, is going to be a skill that you're going to need to know. So this is kind of our intro to, with something you're already familiar with, that being formulas, how can we algebraically rewrite it to be the same formula, but give us a different value. So it's the skill that we're practicing, maybe not so much the practicality of it, if that makes sense. All right. Next one, the area of a circle. The area of a circle is pi times the radius squared. We've dealt with this many times in our math packets thus far. And we want to write a formula to solve for the radius of the circle, meaning we want to get r by itself. Okay? R by itself. So just like the others, what are we doing to R? And let's undo that. We're squaring R and then multiplying by pi. So to undo that, Daniel? Not yet. Okay, remember when we solve an equation for a variable, we work through order of operations backwards? If we're solving for the area, you'd square first and then multiply by pi. So to undo that, we're going to start with that pi, and instead of multiplying, we're going to divide. Yeah. So your first step here is to divide by pi. And that gives us the area divided by pi equals r squared, because on the right side, those pi's cancel out. And here we see the advantage of being a PERMDAS person. Those poor PEMDAS people get to this step and they don't know where to go from here. Because to a PEMDAS person, what's the opposite of an exponent? I don't know. But PERMDAS people, as Daniel said, what's the opposite of an exponent? A radical, a root. So to undo squaring r, we're going to root both sides. The radical and the power cancel out, right? R squared, square root, okay? They cancel out. And we're left with the root of the area divided by pi is going to equal the radius of that circle. Okay? So it's the same opposite operations that we've been doing, but the new wrinkle here is that you don't have numbers to work with. You're doing it with variables only, and the skill being practiced is being able to manipulate an equation with multiple variables to write it in a way that you want it. And you'll see this come up again in graphing, in systems of equations, and parabolas. It's going to be a skill that will be helpful. Okay. I'd like you to try the next two for homework. I believe in you. I think you can do it. The first one is dealing with the circumference of a circle. The circumference equals pi times d. Write a formula to solve for the diameter. And then Albert Einstein is well known for his discovery of the formula E equals mc squared. Write a formula to solve for c. And then you have a question to answer in each of them. Okay, Bridget.
Jim.
Jim?
We got Jim too.
Oh, GYM. I thought you were calling me Jim. Okay.
Jim with the J.
Questions, comments, concerns, complaints, comments, congratulations, or criticisms? Soybe. On?
The baby.
Thank you. A little late, but thank you. Thank you.
Wait, what's a little late?
He congratulated me on my baby, which she's now 22 months old, so but a little bit late.
Whoa.
Swicky, you may. All right, folks, that's high math.